Okay, some of my students were saying that they were having trouble with this item. What we have here is an algebraic expression, and our directions tell us that we need to write that algebraic expression in another way using the distributive property of multiplication. Now, when I look at that problem, I think it's an easy one to solve. And the reason I think that is because I've done enough of these that I'm going to use what I know. This is a math practice. I'm going to use what I know about the distributive property to, number 7 here, change the structure of that problem. So I'm going to go ahead and take all those terms inside parentheses and multiply them by 7k. Okay, everybody ready to watch? So here I have 7k times 3k. So essentially that's like 7 times k times 3 times k. And if I have 7 times 3, that's going to be 21, and k times k is k what, children?
K squared.
K squared, and 21 times k squared is 21k squared. Now, I'm just going to scratch that out so I can focus on here. So here, and I'm not going to go through it step by step like I did here. 7 times 2 is 14. And then I have j by itself. And then I have a k here. And I know k times k is k squared. And then I have 7 times 4 is 28. There isn't another k here, so I say 28k. So I was able to rewrite this expression a different way simply by going in and multiplying each of those terms by the same factor, 7k, and that's what it gave me here. That's what it gave me here. Now, I want to point something out because I've been having students make this error, and I want to squash that error right now, okay? Now, here's what I'm getting at. I've got students who say, oh, why can't we just go ahead and say 21k plus 28k and get like 49k cubed? How many of you looking at that right now, and I'm going to scratch this part out right here, okay? Let's just focus on this part right here. How many of you have looked at this term and this one and thought, why not just add them together and get 49k cubed? How many of you think that makes sense? Nobody's willing to raise their hand because I kind of loaded the question already. I said, you know, people made this mistake all day. The reason that you would not do that is because we're not multiplying 21k squared with 28k, and you would have to multiply in order to get k cubed. You'd have to multiply it. When you're adding it like that, if I have, for instance, if I were to take this k squared plus k, and I absolutely would not get k to the third power. Let's look at this one. Let's say k has a value of 5. Everybody got it? Let's assign it a value of 5. If this is 5 squared plus 5, I'm not going to say that equals 5 cubed. I'm not. Because 5 squared would be 25. 5 times 5 is 25. Plus 5 would be 30, right? And 5 cubed would be like 5 times 5, which is 25, times 5, which is 125, which is way more than just 30. So you cannot just simply add those together and get 5 cubed, or add them together and get k cubed. You just can't do it. It's not multiplying here, it's adding. And I hope that this helped clarify a few misconceptions.